Yeah. Already? Wait, that's not right.
Can you unclick the thingy so I can see the thingy?
It's after.
Have I not shared the screen?
Wait.
Is that what you're saying? I haven't shared the screen yet?
No, it was just your slides were covering up half the notes, so I couldn't see anything.
Can you see it now?
Yes, I can.
Okay.
I don't like being online. It's just miserable.
I know. We're going to work with matrices today. We're going to be doing them manually. We're not going to be doing them in the calculator. Okay? And I'm going to show you how all this stuff works. Talk about some special systems as well. So recall what a matrix looks like. In this section, we'll develop a method for solving linear systems with using matrices. We start with the system and write the coefficients of the variables and the constants as an augmented matrix of the system. Remember, an augmented matrix is just two matrices put together. Okay? So in this case, I have my variable matrix, which is a 3 by 3. Here are my variables on the right side, on the left side. Okay, that's a 3 by 3 matrix. On the other side of the equal sign, I have my constants. So I have a constant matrix. When you take the variable matrix and put it together with the constant matrix, it's now augmented because it's two matrices put together. Okay? How many of y'all enjoy solving a system by elimination? You really like elimination? Okay, folks, what we're doing today, the Gauss-Jordan method, is pure elimination. If you understood the elimination fine, this is going to go great. We're going to take notes as we go through as far as what we're doing, but that's what we're doing is elimination. All right, nothing else to talk about there. This vertical line that's in the matrix is optional. Okay, and you'll notice that when I write these, I don't write that vertical line there. I want all my space available. We have 3 rows and 4 columns. This matrix has a dimension of 3 by 4. Remember that the number of rows is always given first. Here are the things that we can do with a matrix. Number 1, we can interchange any 2 rows. So if I gave you 3 equations, does it matter which one you write down first? They're the same equations, right? So if you were to convert your equations to a matrix and you decided later that you want to rearrange the rows, you can do that. You can swap rows, no big deal. Number 2, you can multiply or divide all of the elements of one row by the same non-zero number. If I've got an equation that's got a bunch of fractions in it, how do you get rid of the fraction? If you've got an equation that has fractions in it, how do you get rid of the fractions?
Multiply by the reciprocal.
Multiply by the
Reciprocal
Greatest common
denominator.
greatest common denominator, right? Did that change the value of the equation? No, because you multiplied the left and the right side by the same thing, right? Remember, in a matrix, each row is an equation. So if you multiply the entire row by a number, it's still the same equation. It just looks different. Okay? And step number 3, you can replace any row of the matrix by the sum of the elements of that row and a multiple of the elements of another row. Okay. In elimination, didn't we try to get like maybe a 2x and a negative 2x lined up together? And then we would add those 2 equations together to make the negative 2's go away? The plus 2 and the negative 2 make the x's go away, right? We're doing the same thing here. Okay? The Gauss-Jordan method is a systematic technique for applying matrix row transformations in an attempt to reduce a matrix to diagonal form with ones along the diagonal, from which the solutions are easily obtained. Does this matrix look familiar? 1, 0, 0, A, 0, 1, 0, A, 0, B, 0, 0, 1, C. Okay? So X is A, Y is B, C X is A, Y is B, Z is C. Right? Whatever those numbers were. Okay? Does this reduced row echelon form look familiar?
Yes.
Why?
Because we went over it.
Where is it? Does that look familiar?
Right.
You would enter the matrix into the calculator, and then you do some math with the calculator. You would go to RREF, okay? And then once you got done, you would get a matrix that looked like this. Okay? The deal is we're doing it manually, not with the calculator. Okay? Here are the steps for the Gauss-Jordan method. Step number 1. In row 1, make that first element a 1. What it says. Once you have a 1 in the first element, step number 2 says use that row to make the first element in every other row a 0. Step number 3. Make the second element in row 2 a 1. Step number 4. Use that row to make the second element of every other row a 0. And so on, and so on, and so on. We're working on making a diagonal of 1s. That's what we're working on doing. Okay? And as we make a 1 here, all of these are 0s. We make a 1 here, we put a 0 above it, and 0s below it. We put a 1 here, we put 0s above it, 0s below it. Put a 1 here, and so on, right? All right, we're going to do this one. By hand, we're going to use Gauss-Jordan elimination to solve for X and Y. Are my X's lined up? Y's lined up? Equal sign lined up? Constants all lined up? Are we good to go to write it in the matrix?
Yeah.
That matrix is 3, -4, 1, 5, 2, 19. Step number 1. I need, in the very first row, the very first element, I need that value to be a 1. I need to do something to turn that 3 into a 1.
Divided by 3.
Okay. I'm going to say multiply by 1/3. Same thing. What I'm going to do is I'm going to take that very first row and multiply it by 1/3. Which is the same thing as dividing by 3, right? Okay. So 1/3 of 3 is 1. 1/3 of -4 is -4 thirds. 1/3 of 1 is 1/3. Okay. As you're doing this Gauss-Jordan method, you're going to kind of keep notes in the margin as far as what's going on. Okay. Currently, this is row 1 and this is row 2. Row 1 has changed. I'm only going to represent 1/3 of row 1 in this first row. I've already done the math in red up there. So 1/3 of row 1 is 1, -4 thirds, and 1/3. I haven't done anything yet to row 2, so I'm just going to write row 2 down again. Questions so far? So step number 1 was to get the first element in row 1 changed to a 1. I'm done. Step number 2, use that 1 to turn everything else in that column into a 0. Cassie, you with me?
Yes.
You're drifting, kiddo. Okay. I need to do something with this 1 to make this 5 turn into a 0. How do you make a 5 go away? Subtract what? Okay, so somehow, some magical way, I need a negative 5 to appear. How can I make a negative 5 appear? Well, it's actually quite easy. I'm going to take that first row and multiply it by negative 5.
Can you do that?
It's an equation. Can I do that? Okay. If I multiply this first row by negative 5, 1 times negative 5 is negative 5. Negative 4/3 times negative 5 would be 20/3. Negative times negative is a positive. 5/1 times 4/3, multiply straight across, right? And negative 5 times 1/3 would be
Negative.
negative 5/3. Okay. So I'm not changing row 1. My new row 1 is 1, negative 4/3, and 1/3. So I'm going to write down that row 1 has not changed from what it just was. Row 1 is 1, negative 4/3, and 1/3. Row 2, however, is going to change. I'm going to take row 2 and I'm going to add to it. I'm going to add negative 5 row 1s to it. Okay? Now, I've already done the multiplying by negative 5, haven't I? Yes.
Why isn't it negative 5 1/3 row 1s?
Because I'm referring to the previous row 1. I'm not going to maintain all that math referring back to the original problem. Okay. I've already done the math with multiplying by negative 5. So all I'm really going to do is combine this line that I wrote in red with this bottom row. So negative 5 and 5 give me
Negative 25.
0. We're just combining. Okay. 20/3 plus 2. What does that give me? 26/3.
Wait, how is it?
2 is 6/3. 20/3 plus 6/3 is 26/3. And if you don't know how to do fractions, guys, you better get familiar with the calculator. And just type in the calculator, press math, enter, and transfer it to a fraction, okay? Negative 5/3 and 19.
(52/3)
52/3. Step number 1. Element 1 of row 1 has to be a 1. Step number 2. Every other number in that column must be a 0. Are we good? Step number 3. The second element in row 2 must be a 1. What do I do to 26/3 to turn it into a 1? If you have a fraction, multiply it by what to get 1? It's reciprocal. So I'm going to multiply this second row by 3/26. 3/26 times 0 is 0. 3/26 times 26/3 is 1. 3/26 times 52/3 is 2. I'm happy with my row 1, I'm leaving it alone. Row 1 is 1, negative 4/3, and 1/3. But I just changed row 2, didn't I? I took this row 2 and I multiplied it by 3/26. And that gave me 0, 1, and 2. Step number 1, get a 1 in the very first cell. Step number 2, put zeros everywhere else. Step number 3, make the second element in row 2 a 1. Step number 4, make everything else in that row, in that column, a 0. I need to turn this negative 4/3 into a 0. What do you add the negative 4/3 to make it a 0? Positive 4/3. So I need to make this 1 a 4/3. So I will multiply this row by 4/3. 4/3 times 0 is 0. 4/3 times 1 is 4/3. 4/3 times 2 is 8/3. We're about to replace row 1. What am I adding to row 1? 4/3 of what?
Row 2.
Okay, so I'm taking row 1, I'm adding 4/3 of row 2 to it. I've already done the math for the 4/3, so all I'm doing is combining my red numbers with my row 1. 1 plus 0 is 1. Negative 4/3 plus 4/3 is 0. 1/3 plus 8/3 is 9/3, but 9/3 is 3. What's X? 3. What's Y?
2.
So the solution is the ordered pair 3, 2.
Wait, hold
Preferred
on, just a
explanation.
moment. I'm still a couple steps behind you.
This is what the calculator does when you do RREF. We're about to do 3 equations and 3 unknowns.
Wait, no.
Before I do 3 equations and 3 unknowns, any questions on what's happened here?
I don't even know what to ask, to be honest.
Yeah, you're right.
I'm just processing it.
Well, Hannah Reed's gonna explain the next one to us.
Hey.
She looks lost. Jeez. I am still trying to catch up on these notes because I'm still trying to understand why is this useful.
Wait, no. Oh my goodness, I still don't. Okay.
We'll screenshot it.
I screenshot it.
Okay.
I think I prefer the
I just don't
calculator
even know
doing
what
it.
to do.
Well, everybody's gonna prefer the calculator
Why can't we use the calculator?
because you will see a test question that talks about what would be the next logical step in solving this. And it's gonna have different values and you need to pick the right one.
Put it in the
Yes.
calculator.
You can't do it in the calculator when it says what's the next row. You get the answer. But that's not gonna help you on an intermediate step.
You could guess.
Can you write those equations down? You got paper out. Can you take notes? Okay, I'm gonna log you off. You're not taking notes.
Oh no. What makes you do
Not an
this?
option, but you're not using it anyway, just close it. Is our matrix set up nicely already?
Yes.
Don't need to change anything? Okay. step number 1. Element 1 of row 1 needs to be made into a 1. Are we good?
Yes.
Step number 2, using that 1, we need to make the other ones turn into zeros. I'm gonna use multiple colors on this one because we have a lot of stuff going on. Okay, so we are currently happy with row 1. Row 1 is 1, -1, 5, and -6. What do I need to do to row 1 to make the 3 in row 2 go away?
Divide by 3. Or
Multiply it by 3.
Negative.
-3.
Yeah.
So if I take row 1 and multiply it by -3, I get -3, +3, -15, +18. Row 2 is now going to be replaced. Row 2 is going to be replaced by taking row 2 and adding to it what?
B1 or row 1.
-3 row 1.
-3 row 1s. -3 and 3 combine to 0. 3 and 3, 6. -15 and -1, -16. 18 and 10, 28. I still need to use row 1 to make the 1 in row 3 go away. How do I do that? Multiply by -1. By multiplying row 1 by -1, I get -1, +1, -5, and 6. I'm now going to replace row 3 with row 3 plus -1, row 1. So I'm going to take my bottom row and replace it with my purple numbers. -1 and 1 is 0. 1 and 3, 4. -5 and 2, -3, 6 and 5, 11. Luke, what's the problem?
Oh, I was just confused for a moment there.
You good?
Yeah, I was just looked at the multiplied by row 2. So I was confused for a moment.
Oh, the purple rows?
Yeah, I just thought you were multiplying it by row 2.
Yeah. I tried to squeeze up there with it. I understand that. Y'all following the colors? Does that help you a little bit? What's going on? Okay, are we happy with column 1? Yeah, column 1 looks good. Now move to column 2. Okay? I need to turn that 6 to a 1. Or if you wanted to, you could actually swap these rows, right? And turn that 4 into a 1. Now, looking at this problem, there's no advantage either way. Okay? So the way it is, I would leave it like it is. How can I turn that 6 into a 1?
Divided by 86.
Divided by 6, multiplied by 1/6. Okay? So I'm going to take 1/6 of row 2. 1/6 of 0 is 0. 1/6 of 6 is 1. 1/6 of -16 is -16/6. But -16/6 reduces to -8/3. And 1/6 of 28 reduces to 14/3. So, I'm leaving row 1 alone. Row 2, I'm taking 1/6 of my row 2. That's nice. Which is 0, 1, -8/3, 14/3. And row 3, I'm not doing anything to it right now. Now that I have a 1 in the second column of row 2, I need to use that 1 to make all the other numbers in that that column, a 0. What do I have to do to row 2 to make the -1 in row 1 go away? Anything?
Add it to row 1.
Just add them together? Okay. So you're telling me then that row 1 is going to be replaced with row 1 plus row 2? And it's that simple? And that's correct. Combine these. 1 plus 0 is 1. -1 and 1 is 0. 5 and -8/3 is 7/3. And -6 and 14/3 is -4/3. If you want to key those in the calculator to double check me, it will not hurt my feelings at all.
Wait, did you say that's 7/3?
This one?
Yeah.
Currently, row 2 is my working equation, so I'm not going to do anything with my new row 2. So it's just 0, 1, -8/3, and 14/3. But row 3 needs some math. My working row right now is row 2. What do I need to do to row 2 so that when I combine it with row 3, the 4 goes away? That's it, multiply by -4. -4 times 0 is 0. -4 times 1 is -4. -4 times -8/3 is positive 32/3. And -4 times 14/3 is -56/3. So row 3 is row 3 plus -4 row 2's. 0 and 0 combine to give me 0. -4 and 4 combine to 0. 32/3 and -3 combine to 23/3. Because this is 32/3 minus 9/3. 32 minus 9 is 23. And -56/3 plus 11, that'd be -56/3 plus 33/3. Which is going to be a -23/3. Okay. And again, if you're struggling with fractions, you got your calculator. Use your calculator, do the math, push math enter, and it's going to fix it for you, okay? So now I've got row 2, column 2 is a 1, everything else is a 0 in that column. I now need row 3, column 3 to be a 1. How do I turn 23/3 into a 1?
Multiply it by 2/6.
Multiply pi by the reciprocal, which is 3/23. Row 1's good, leaving it alone. 1, 0, 7/3, -4/3. Row 2 is good. 0, 1, -8/3, and 14/3. Row 3, we've just changed. To 3/23. Row 3, which gives us 0, 0, 1, -1. We have one more matrix to do. I need to get rid of the 7/3 in row 1. How do I get rid of the 7/3 in row 1? Multiply row 3 by -7/3. That gives me a -7/3 here and a +7/3 here. Row 1 is going to be combined with -7/3 row 3, which gives me 1, 0, 0, and 7/3 minus 4/3.
0. Wait, 7/3 minus 4/3, that's 1.
3/3 or 1. Row 2 is going to be replaced. How do I get rid of a -8/3?
Make it 0.
How?
Then you subtract it. Or add 8/3.
I need an 8/3, so I'm going to multiply row 3 by 8/3. Gives me a 0, 0, 8/3, -8/3. So row 2 is row 2 plus 8/3 of row 3. 0 and 1 is 0. Sorry, 0 and 0 is 0. 0 and 1 is 1. 8/3 and -8/3 is 0. 14/3 minus 8/3. 6/3, which is 2. And I'm happy with row 3 the way it is.
So after we did row 1 plus -7/3 row 3,
Okay.
couldn't we plug in the values for x and z and find y?
Oh, of course. Of course. In reality, if you were doing this problem manually, I would not have changed, I would have left row 1 alone here. I would have only used row 2 to get this 4 into a 0. And that would have given me that z was -1. And once I knew that z was -1, I could have plugged it in here. And then I could have got that value for y and plugged y and z into here. Okay. What's x? 1, y,
2.
2, z.
-2.
Wait,
Or
let me
-1.
snapshot this real quick.
Okay.
Why does it do that? Oh my gosh. It covers up the bottom of it. Anyway.
How we doing online? Okay.
I feel like the elimination better.
This is elimination.
Let's took up the whole page.
away.
I got lost halfway through, so I just wrote down what you were doing and gave up trying to.
Next system. Guys, when you get lost, stop me and ask a question, please.
I don't know
What
what
if we
to
don't know what
ask.
to
Yeah, I
I'm just lost.
I just stopped writing. You just went on, so I was like, yeah, it's too late to go back.
This is a lot.
Okay, this one's gonna be quick and easy.
You sure?
Okay, so
Go ahead.
if there was like you said this was like kind of like elimination, why don't we just use elimination instead of doing this long thing?
Because
Like
this is
why?
because this is what Mr. Gauss and Mr. Jordan came up with.
Yeah, but how are you that bored just to create a map thing? Like that's
They
get a
should
life.
stay quiet.
Okay,
Is there any way to shorten it?
I guess you can take up less paper by writing smaller. Okay,
So sweet.
now, what is an inconsistent system?
No, consistent.
Not consistent, what's that mean?
It's not the same all the time.
A system can be consistent or inconsistent.
Oh, it's not like it's like let's say you
It
have X,
doesn't
Y,
work.
X, Y, and then you just went to like Y, Z, I don't know,
Doesn't
different pattern.
You drowned.
There's no solution, guys.
Oh, that.
A system is inconsistent if there's no solution. This system has no solution. And we're gonna look at it by solving using Gauss-Jordan method. Okay? So it's already set up well for us to set up our matrix. And the first element in column 1 is already a 1. And I need to use row 1 to get rid of the 2 in row 2. What do I need to do to row 1?
Multiplied by -2.
Multiply by -2, which gives me -2, -2, -4. Row 1 is not changing. Row 1 is 1, 1, 2. Row 2, however, is changing. Row 2 is going to be row 2 plus -2 row 1s. Combine those, what do you get?
0, 0,
0, 0,
1.
6.
Oh, just kidding. Oh wait.
Oh, yeah,
0,
that's-
0, 1.
Yeah.
Okay. What does that last row tell us?
Oh, that.
0x
Oh, no.
plus 0y equals 1. That second row tells me that if I have nothing and I add it all up, I get 1.
No.
And that's not how life works. Right?
That's why it's inconsistent.
This is no solution.
I thought this was gonna be some long thing.
Okay?
Yeah, I was prepared.
There's 2 other ways of writing no solution, and you might see both of these on doing your homework. You might see it written as a couple braces. What's inside those braces? That's called the empty set. That's the set of numbers containing nothing. Nothing is not the same thing as 0 though, right? 0 is a defined point, okay? Another way of writing no solution is like that. So it's possible to see any of those. Yes, ma'am.
What's the equal sign with this last one?
Not equal to.
Oh, there's a rule.
Guys, with 5 minutes, I'm just gonna stop the recording. I don't want to, tomorrow is a work day, but we will finish this tomorrow at the beginning of the period. I'm gonna stop the recording now though.
I really like this map.
I understand what it's.
Oh!
Before, I was
Your
like,
Cassidy's got throbbing ears. Can't even hear.
my ears don't hurt, but my head. Well, no, when I was a kid,